G'day everyone, it's Carl Thompson here from StorageCraft Asia Pacific, and today I'm doing a webinar on the HeadStart Restore solution. So the first thing I'm going to use is just a quick little PowerPoint to help explain how HeadStart Restore works in the StorageCraft solution. So the first thing we have up the top left is showing your production servers on site using ShadowProtect continuous incremental backups to an image repository. This is showing a BDR appliance, and I can use this to show you the server fails. We've got our virtual boot technology which can recover directly off those compressed images. Where HeadStart Restore fits in is the next step. It's an enterprise solution or used for migrations, where instead of virtual boot we can continually push those incremental images into a Hyper-V or VMware environment for very quick recovery. So enterprise, because it requires that additional infrastructure at the target of where these images are going into, but also that is meaning that the machine is now in an uncompressed VMDK, VHD, VHDX file, so you're going to see performance. You can spec that similar to what you have in production. Virtual boot, you are going to have a bit of a hit with those compressed images and that kind of thing. So that's all I wanted to show you there. I'm just going to pull up the StorageCraft website and just have a quick discussion around the information we have online. So HeadStart Restore is an automated function as part of ImageManager. It lets you start a restore operation on a new system while the original production server continues to run. ShadowProtect continues adding incremental backup images to the image chain on the original server. This greatly reduces downtime associated with various failover operations, particularly for systems with very large storage, i.e. multi-terabyte. So just jumping across to the restore scenarios, there's three types of scenarios I guess commonly used with HeadStart Restore. One's for a virtual server migration. So you're backing up a physical server, the HeadStart Restore can lay down that huge base image and any increments while that physical server is still running. We can then do a final backup and shut down that physical server. HeadStart Restore only has to push those last incrementals across, and we can be back up and running in a virtual environment very quickly. So great for that type of migration. Also a hardware failure. So again, you're already running HeadStart Restore in advance. If there's ever any type of failure, you just finalize that job and we can get up and running very quickly. And virtual standby server. So not only in a failure, but we can finalize a HeadStart Restore and actually just isolate that environment and use it for testing as well. So there's lots of different scenarios where it could be great for a sandpit or testing off production or for actual DR or migration. So let's go in and take a quick look at ImageManager. This is a free software. It's required for ShadowProtect continuous incrementals. The three main functions of this is VCR, verification, consolidation, and retention, and that is required for ShadowProtect continuous incrementals. The HeadStart Restore function is a licensed feature on top of the free ImageManager software, and it's licensed per server or per managed folder. And if you just had one license, once the HeadStart Restore job's done, if it was a migration, you can reuse that for another server. It's just continually, it's licensed per continually running jobs, and it is typically designed to run continually across all of your servers for a disaster recovery scenario. So what I'm going to do is we'll go in and add a job. Just first I will explain under licensing here, this is where you can go in and put in a serial number when you purchase your restore jobs, and then you can go into HeadStart Restore job, and as I go through this I'll explain how it works. So I'm adding a HeadStart Restore job to this managed folder here where I've got a backup chain in it, and you'll see here we can give it a name, so HeadStart Restore of Exchange Server, that's the name of my server, and the type. So our type, we've got a couple of options. VMDK, obviously for VMware, VHD or VHDX, obviously for Hyper-V. For VMDK, we get some options around the destination. Obviously, if I save it to a local drive or a network drive, it's going to save it in a format for VMware Player. But if you specify ESX, ESXi, that's going to allow us to save it directly into the data store. So let's take a look at this option first, and then we'll come back and perhaps look at the other options. So select ESXi. Location, we now need to add a location to an ESX or ESXi server. If you are ESXi, you need to have the storage API function as part of that environment. So you put in your host and you authenticate with your root credentials to that host. I've already got an existing one here set up. There's no subdirectory required for this. It's going to ask us for a data store at a later stage. Now, for the lag time, we can obviously specify here what the lag window is that we want to commit to this virtual machine. Now, I'd suggest most people set this to around 4 to 8 hours, sometimes even 1 day, but obviously we can go right up to 30 days or down to a minimum of 1 hour. Now, the best way to explain this is it's going to commit everything up until 4 hours ago continuously. So as soon as I hit save, it's going to push that base image in, my monthlies, weeklies, dailies, intradailies up until 4 hours ago. As new ShadowProtect backups come in, ImageManager will automatically verify them, and once that file is over 4 hours old, it'll automatically be pushed into this VMDK. So I'm going to leave that at 4 hours, and we'll see what actually happens when I go through this process. If I now go to HeadStart Restore Volumes and add the volumes, we can see here it's found the C and D backup images in this folder I'm managing, and I need to put in my encrypted ShadowProtect backup password that I had specified earlier. Click OK. And what it's got here is the base image, the SPF, it's an 80 gig volume, and the D drive was a 60 gig volume. So I now need to choose the destination or the target for where this is going. So if I click Browse for Volume, it's now going to connect to my ESXi server. And here we go, here's the host that I've connected to. I've got an existing virtual machine set up here, but what we can do is click down here, create a new empty virtual machine. So this is going to connect to the host and create a virtual machine for me. So I'll just call this test01 and choose the default data store for this virtual machine and click create. So this is going to pre-create a virtual machine with VMware default settings. I can then click on this little button here, create new empty virtual disk, and attach it to this new virtual machine. So I click this button, and again we can specify a data store or just store it with the virtual machine, which I'll do today, and I'm just going to type in C drive. So it's going to create a C drive VMDK, and it's pre-filled in the capacity. Obviously I could increase this further, but I can't go smaller. You can see there the minimum. I might say, look, this is a migration, I want to actually make this a bit larger. Click create. So that's going to go and create that VMDK in that data store, and then I'm just going to click select. Now you can see here the volume is C drive VMDK for this 80 gig C drive base image, and then I'm going to do the same thing for the D drive, except this time I'm just going to select that existing virtual machine we just created. So there's test01, there's that C drive VMDK. I'm going to click on this file here, create a new empty virtual disk, D drive, again 60 gig minimum, click create, and I'm going to select that as the target for my, my D drive. And then basically that's it, it's that easy. I now just click save. And now what it's doing is the longest part of any restore. Regardless of whatever technology you use, it's restoring that base image. That's what takes the time, and then obviously it's now working through, once it's done the base, it's working through those ShadowProtect incremental images. So my D drive will turn around fairly quickly here because there's not much data in it. The C drive base image might take a couple of minutes. So we're just going to let that run. What I'll do is while it is running, I'll go in and add, and we'll talk about a VHD file option, or saving to a local or network drive. So if I select, let's say VHDX on this instance, destination, so you can choose to save it in a local drive if this was the Hyper-V host, or we can save it to a network drive, perhaps a partition or a volume on a Hyper-V server on the network. I'm just going to select local drive. I've got an existing folder set up here, and we've got a subdirectory. It's going to create a subdirectory and store these VHDX files in there. Again, we can specify any type of lag time here. Maybe I'll leave this one at 1 hour. You'd reduce that down to the minimum if it was a migration to make it turn around quicker. And again, I will talk about this in a minute. So again, for the volumes, add in the C and D drive, put in my encrypted password, click OK. And this time that's it. I don't need, there's no facility here to pre-create a virtual machine, so that's something I would, I'd maybe go and export my VM settings and import into my standby Hyper-V if I wanted to use the same settings, and then just attach these VHDX files in the event that I need them. So I'm just going to click Save here, and now I've got a second job running. So this is now actually occupying 2 licenses, but it's going through there and restoring these images to the appropriate places. The top one's the Hyper-V one, the VHDX files, and the bottom one's the VMware one, which is still going through the restore process. So very easy, and it's completely hardware independent, so it doesn't matter if these backups are from a physical server, any version of VMware or Hyper-V, or any one of our supported environments. It's going to convert those backups into this format, and if you have completed a migration, i.e. you've gone from one type of platform to another, there is a final step of launching our recovery environment just to do the very quick hardware independent restore, where we'll just sort out those drivers and make sure that Windows doesn't have any sort of blue screen. Now, just while this is running, I just want to back up a step here and just talk about a little diagram I've made here. I like using this diagram to explain how the solution works. So again, I showed this earlier, the production servers using ShadowProtect continuous incrementals to an image repository. In this case, it was a backup server for that virtual boot functionality. The virtual boot tool is a free part of ShadowProtect. The HeadStart restore licensing is part of ImageManager, an additional licensed feature, but that's giving us this enterprise disaster recovery where instead of virtual boot, we're continually pushing these images into a VMware environment. If you were to use virtual boot, you could use it for some servers, perhaps more critical ones. You could use HeadStart Restore, so you can certainly mix them. If you were using virtual boot and you wanted to get back to production, we have a free tool called a manual HeadStart Restore, and this is just simply you're booting up a production server off the ShadowProtect recovery environment. While you're running in virtual boot, you can restore the base image and any incrementals, and without finalizing it, we can come back to virtual boot, do a final backup and shut down, and then using the manual HeadStart Restore, we can restore subsequent incrementals and then finalize. So it allows us to turn it around very quickly, but it is more of a manual, it's more of a pull process. It's pulling the images from here down to the environment. This HeadStart Restore licensed feature of ImageManager is more of a push. It's an automated process that continually pushes new increments once they reach that lag time into the destination. And let's go and have a look and see where we're at with ImageManager. So I can see here the Hyper-V one's finished. It's a bit quicker. I was actually, my destination on this one was an SSD, so that's nice and quick. So the Hyper-V VHDX, let's work on this one for a minute and I'll come back to VMware afterwards. It's now restored everything up until 4 hours ago or the last 2 increments. It'll always leave a buffer of the last 2 increments. What that means is if I get a virus from an hour ago, I can quickly go back to something, maybe an hour and 15 minutes ago and finalize that. So it's, that lag time's giving you a buffer if an update went wrong or you had a virus that you can very quickly go back. It hasn't committed those incrementals. Anything over 4 hours ago is already committed. I'd have to start off a new job and increase that lag time if I wanted to change that. So there are ways to deal with it, but typically you're working within that 4-hour lag time. So let's say the server just died. I just simply click this green button, Finalize HeadStart Restore, and the default option is to automatically pick the most recent image. So selected C&D drive is pre-selected. The default is to pick the most recent one to say, look, the server just crashed. I need to get it straight back up and running. But of course, I can go down and choose, between the last 4 hours or the last couple of increments and actually finalize back in time within that lag window that I've specified. So I'm just going to select automatically pick the most recent, click finalize, yes to confirm, and what you'll notice is that all it's got to do is push those last 3 increments through and that's finalized. So you can see here we've got the nice green tick over here, very fast turnaround to finalize. Now if that original server was in Hyper-V and I'm gone to the same version of Hyper-V with these VHDXs, that server is now ready to boot. If I'd gone from a physical server into Hyper-V, there is that final step of just simply booting up the virtual machine off our recovery environment. It takes about a minute to boot up into ShadowProtect. Then you just run the hardware independent restore tool. That takes about 30 seconds. Then you're done. You can just exit out of it. It'll automatically reboot and you're back up and running. Obviously, once this is done, I can delete the job. That is just occupying a license. I don't need to leave it there. If we go and take a look under my iDrive HeadStart Restore volumes, there's the subdirectory it created, and here's my 2 VHDX files. Now you'll notice these other files here, HSR files. Let's say my backup server failed. It just the ImageManager server failed and I need it, or the building's gone but the Hyper-V server's okay, or it's in a different location, we can use these to finalize what is in this file at this point in time and get them up and running, because it needs that final finalization process to close it and allow us to use it. So that can be done from our recovery environment as a manual method in the worst case scenario. So that function's there. You'll notice when I deleted that job, it didn't delete those VHDX files, so you don't need to worry about losing anything, killing a job. Now, this is the VMware, the ESX option that I've got. I'm going to finalize this one as well. The same option. I can go down and choose different recovery endpoints, and we can see here the destination, so it's giving us a bit of clarification. I just simply click Finalize and go Yes. And actually, I'll just click No for a second. This one here I had a 4-hour lag time. The other one I only had a 1 hour, so that's why I'm seeing more options available here, because I had a longer window of lag for this job. So I'm just going to click Finalize, Yes, same thing. This time it's got to push 4 hours. So in this case, it's only an extra increment because I'm just doing backups every now and again in a demonstration environment. It's not running every 15 minutes as you would typically see in a production environment. So we can see here the D drive's finalized. Again, the C drive's got a bit more data in it, and that's finalized too. So very quick turnaround. Even in a production, it might take an extra minute where you've got a bit more data change, but you're only talking 4 hours worth of increments or a day. It's not going to take a huge amount of time to turn this around. So if I just X out of this job now that it's done, I can kick off another one if I wanted to. But let's just go and take a look in VMware and just see what's actually been set up here. I'm just going to log into this host. And it's just important you understand what it has done here in vSphere. So if we scroll across to Test01, this is the virtual machine it just created. There are some very critical things you need to be aware of when it creates this machine. It's just using a VMware default setting. So it's defaulted to memory to 1 gig. So, increase the memory. You want to sort out how many cores, etc. SAS controller, you're typically going to be changing this to your SAS. What else would you change here? You might need to adjust your networking. Under options, one of the key ones is the machine type, the guest operating system. You need to make sure that's got the relevant operating system on it and that kind of thing. So there's some basic settings you need to go into and tweak. If you've done a migration, you might tell it to boot into the BIOS the first time, so you can load in off your data store our recovery environment ISO. So that's always a good thing to have in your data store in case anything goes wrong, is boot off our recovery environment, and we've got options around fixing stuff, repairing things, hardware independent restore, that kind of stuff. So lots of options if we need to use them. But if it was the same version of VMware that we've gone into, typically you're ready to go straight away and just power up that machine. So that's all I wanted to go through today. Very brief overview. We will do a more in-depth one where we can go through bringing up the machines and showing you those different scenarios in action. So hopefully this has been useful for you. Again, my name is Carl Thompson from StorageCraft Asia Pacific, and I thank you for attending my webinar today.